Hey guys, Mr. Backerberg here. In this video, we're going to look at integrals on a calculator. So we've used our calculators to approximate that LRAM, MRAM, and RRAM, but most modern calculators actually have sophisticated built-in programs that are going to converge to an integral with better speed and better precision than our program that we wrote can. So if you have a TI-84, then as you're looking at integrating some function from A to B with respect to that x variable, the command that we're going to look for is this fnint. So this is your function numerical integration. And if you have an older model calculator, the way you're going to have to type it in is your function first, the variable to which you are integrating with respect to, so for us that's going to be x, your lower limit of a, and your upper limit of b. Now if you have a newer model calculator, it'll look slightly different. I'll show you what both ways look like in this first example, but then when I do the second two examples, I'm just going to do it with the newer model calculator. So we're going to use our calculator to numerically integrate the function x times the sine of x dx, and we're going to integrate that from -1 to 2. Now as I do this first example in my calculator, I've got it set up for the older model first. I'll run through that one, and then I'll switch it over so that it has that newer model look to it, and then we'll run through it again. So to find that command, I'm going to hit math, and then I'm going to arrow down. It's this fnint that we want. So the very first thing that we have to type in is our function. So our function was x times the sine of x. Now, when I typed in the sine, it opened up a set of parentheses, so I have to close that set of parentheses. I have to put in a comma, and then our variable that we're using, this is an x variable in here. Our lower limit was -1, and our upper limit was 2. So all of that information gets put into this set of parentheses for our numerical integrator. I hit enter, and it gives me an answer of about 2.04. Now I'm going to switch my calculator over into the newer mode so we can see what that looks like as well. So now if I hit math and go down to that numerical integrator, number 9, it's going to put the actual integration symbol in there. So our lower limit was -1. Our upper limit was 2. Our function was x sine of x, close up the parentheses that opened up for the sine, and then our variable that we're doing the integration with respect to is x. Now if I hit enter, I also get an answer of about 2.04. So regardless of how your calculator actually looks, whether it's an older model or a newer model, it does the calculations the exact same way. We get the exact same answer. It just looks a little bit differently on our screen. Our second example, we're integrating the function 4 over 1 plus x squared dx, and we're going from 0 to 1. Now I've got my calculator set up in the newer mode, so if you have an older model calculator, you have to know how to type it in for this numerical integrator. Our lower limit was 0. Our upper limit was 1. Our function was a fraction, so I have to do math. I'm going to go over to fraction, and on top of the fraction, I had 4. On bottom of the fraction, I had 1 plus x squared. If you've got an older model calculator, then as you're typing in this fraction, you want to do that top number divided by parentheses, and then this bottom stuff, 1 plus the x squared. Our variable in here is x. I hit enter, and that gives me an answer of about 3.14 if we do a little rounding there. And then our last example, we've got the function e to the -x squared dx, and we're integrating that from 0 to 5. So in my calculator, I go math, I go down to that numerical integrator. Our lower limit was 0, our upper limit was 5, our function was e to the -x squared, and our variable again is x. I hit enter, and I get an answer of about 0.89 if I round that one off. That's going to be it for this video. Thanks for watching.